Hello everyone, how are you all? Welcome to my channel. Student, nowadays we are discussing the chapter Magnetic Effect of Electric Current. Previously we discussed some topic in this chapter like electromagnetic induction and Faraday's law. I hope you have completed the topic electromagnetic induction and Faraday's law. Student, today we will discuss the direction of that induced EMF. You know, the induced EMF generated in a closed circuit by the law of electromagnetic induction. Okay, a closed circuit is there, and when magnet is moved, magnetic flux is changed through that circuit. Induced EMF generated in that one. So the direction of induced EMF or the direction of the current, what will be the direction of the current? So today we will discuss about this, and also we will discuss about the Fleming's left hand and right hand rule, which are most important topic. And we will also discuss today about the DC motor. DC generator is also the part of the chapter, but this time CBSE deleted some portion of chapter, some portion of the syllabus for this year only. So DC generator is also deleted. Okay, but today I will tell about some the principle of the generator also. So let's start. Okay, so first is what will be the direction of induced current in the circuit. Okay, so let's see. Let's suppose this is a circuit and there is a galvanometer. We studied it previously also. Okay, and there is a magnet. This is north and south. Okay, if flux linkage will change through this circuit, so the EMF will induced in this circuit, and that induced EMF will generates the current in the circuit. We already studied. Okay, so what will be the direction of the induced EMF generated in this circuit? So how can we find that once? So we can find it one by the simply the law is given by Lenz Law. Lenz Law. Okay. So Lenz is saying the polarity of induced current as his is such that which opposes the direction, which opposes the cause of generation. Okay. So what is the cause of generation of the induced EMF here? The change in magnetic flux. So the polarity of that induced EMF, that induced current will be such that which will oppose the change in magnetic flux. Okay, change in magnetic flux. यानी ये जो इसकी polarity कुछ ऐसी होगी जैसे change in magnetic flux का ही oppose करे, because the originate, the responsible for the generation of current is here only change in magnetic field. And how magnetic field is changed here? By the moving of the magnet. If magnet coming towards it, either magnet going far than about. Okay, but only the responsible region. What is the region? Why is current is generating here? Only the region is that because magnetic flux is changing. So the polarity will like this, which will oppose the change in magnetic flux. Okay, so how changes magnetic flux here? By moving the magnet. So it means it will oppose the moving of magnet. How can it be possible? Let's see. Okay, let's suppose this is a north pole and this one is south pole of the magnet. Let's suppose this time magnet is coming towards this circuit. Okay, now what will be the direction of current this time? The direction of current will such that where this pole should be north and this one should be south. Why? अगर ये pole इसका north होगा and this pole would be south, तो क्या होगा कि north and north will repel to each other, because this is the north pole of the magnet, and this will be, if this will be north pole of this coil, this circuit, this north and north will repel to each other. So what is opposing? It opposing, ये magnet इधर की ओर आना चाह रहा है. It coming towards the circuit, but it opposing because this of this polarity, because this is a north pole and this is again north pole. North and north will repel to each other. Okay, so the direction of induced EMF is such that which will oppose the change in magnetic flux. Okay, let's suppose अब ये magnet आपके इधर की ओर जाए, ठीक है? If it will far away than this circuit, so what will happen? Now this, अभी तो ये magnet का north pole है, north and south are fixed. Magnet is moving far than the circuit, so what will happen? This north pole and this circuits now previously it was a north pole, now it become a south pole and it will be a north pole. If this will be a south pole and this is the north pole of the magnet, so what will be happen, student? This south and north will attack to each other and it is opposing the movement of this magnet. So what we see? We saw this north and south pole are this time attracting to each other when magnet are going to far away than the circuit, and secondly when the first we saw if this was a north pole and this was a south pole, that condition, this was a north and north were repelled to each other. So समझ में आया आपके? So what will be the polarity of that induced EMF? The polarity has the induced EMF is always in the direction such that in which direction it always happen this direction where it will oppose to the magnetic field, magnetic flux. जहां से मैग्नेटिक फ्लक्स आपका चेंज हो रहा है, क्योंकि करंट सर्किट पे किसके कारण है? मैग्नेटिक फ्लक्स के चेंज होने के कारण. If the change in magnetic flux will stop, obviously current will stop. It is the Faraday's law. Okay, so it will always oppose the change in magnetic flux. So this law is given by Lenz law. कभी इससे एग्जाम में स्टूडेंट 10th के एग्जाम में बोर्ड में इससे क्वेश्चन आता है, ठीक है? डायरेक्शन आइडेंटिफाई करने के लिए क्वेश्चन आता है. Okay, so student, we can give the direction of the induced EMF or that induced current by the Fleming's right hand rule also. Okay, so what is the Fleming right hand rule? देखिए, previously we also discussed the right hand rule, that was a right hand thumb rule, ठीक है? वो अलग है and this right hand rule is different than that. So this right hand rule is used in a in electromagnetic induction में हम इस right hand rule का use करेंगे. Okay, so what is that? देखिए, if we will if our fingers are like this, if we will arrange our finger in this manner, there is all fingers, this is our middle finger, this is first finger, okay, and this is thumb. If we will arrange our finger in this manner, our thumb, first finger and middle finger are mutually perpendicular to each other, means ये सब perpendicular. देखिए, ये इसका 90 degree, okay, and these are also 90 degree. इसकी बात करें, ये भी 90 degree है, okay. So these all three fingers are in 90 degree, okay. So in that condition, this thumb will represent the motion of the conductor, okay, and this finger will represent the magnetic field or magnetic flux, magnetic field, okay, and this middle finger will represent the induced current, induced EMF in the circuit. Is it clear? Student, किसी भी circuit में current कैसे induced होगी? Either magnet will move or conductor will move. If any conductor will move in a magnetic field, किसी magnetic field में कोई conductor अगर move करता है, ठीक है, in that conditions a induced EMF will generate in the conductor. This is the principle of DC generator also. देखिए, समझते हैं. Let's suppose this is a magnetic field. मान लीजिए ये कोई फील्ड है मेरा, ये नॉर्थ पोल है और दिस इज द साउथ पोल, ठीक है. ये कोई मैग्नेट है, दिस इज नॉर्थ पोल एंड दिस इज द साउथ पोल ऑफ द मैग्नेट, ओके. सो बिटवीन द नॉर्थ एंड साउथ obviously in this region there will be a magnetic field. Okay, यहाँ पर एक strong magnetic field होगा. If इस strong magnetic field में obviously magnetic field line होंगी, आपको पता है ये magnetic field line north to south होती है. ठीक है स्टूडेंट. So let's suppose there is a conductor. ये कोई ऐसा मेरे पास कंडक्टर है, ठीक है. ये इस तरह से rectangular portion है इस कंडक्टर का. This is let's suppose this is a conductor, and if it will continuously moving in this field, so what will happen? It will across the conductor. ये कंडक्टर अगर ऐसा है, okay, let's suppose this is a plate type conductor. If this will move in this magnetic field, so what will happen, student? The magnetic field will across this conductor will changes. Obviously, magnetic field with this conductor will magnetic field across this conductor will change. So whenever the magnetic field across a conductor has changed, what happens? The induced EMF will generate in the circuit, and that induced EMF will causes a current in the circuit. अगर ये आपका circuit close है, ठीक है, let's suppose ये आपका close circuit, ये मैंने कोई load दिया है यहाँ पे. Okay, so क्या होगा? इस north और ये south pole है, इसके बीच में strong magnetic field है. Strong magnetic field में this conductor plate is moving continuously. If this will move continuously in this magnetic field, so magnetic flux will changes across the conductor, and that change in magnetic flux will result the induced current. So what will be the direction of the induced current here? So this direction of induced current, जो इसमें induced current है स्टूडेंट, उसकी डायरेक्शन को हम कैसे फाइंड करेंगे? उसकी डायरेक्शन को फाइंड करने के लिए we will use here Fleming left hand rule, and this is the principle of DC generator. What is the principle? Whenever in any magnetic field, whenever a conductor moves in a magnetic field, flux linkage will change through across the conductor, and an induced EMF will set in the conductor. Okay, so what will be the direction of that induced EMF? We can give the direction of that induced EMF, induced current in this circuit by the Fleming's right hand rule. So I am applying the Fleming right hand rule here. देखिए स्टूडेंट, लेट्स सपोज अभी आपका ये जो पोर्शन है इस तरह से, ठीक है. नाउ ये कंडक्टर जब मूव करेगा, सो अभी आपका ऐसा है, ठीक है. नाउ लेट्स सपोज नाउ इट इज मूविंग, एंड दिस पोर्शन, देयर आर टू पोर्शन, फर्स्ट एंड सेकंड. आई कैन नेम दिस वंस ए बी एंड सी डी. व्हेन ए बी पोर्शन, ये जो वायर है ए बी वायर जब मूव कर रही है आपकी, इनवर्ड मूव कर रही है, अभी अंदर की हो जा रही है. सो अप्लाई दी Fleming right hand rule. So what is the right hand rule? This is the motion of the conductor magnetic field, and this will be the direction of induced current. So what will be the direction of induced current in this wire? देखिए magnetic field कहाँ की ओर है? आगे की ओर, north to south. So this finger is towards the magnetic field. Okay, motion of the conductor, this thumb is represent the motion of the conductor. So motion of the conductor is inward to the board. So motion of the conductor is inward to the board, and this middle finger is going downwards. So what was the direction of the current here? Downwards. Is it clear? आसान है. Okay. So what will be the direction of the current? A to B. Okay. Now simultaneously, when this portion will move inward, obviously this will C to D, this will move outward. Apply here again Fleming's right hand rule. देखिए this is the direction of magnetic field. Okay, and this is the direction of what? Motion of the conductor. Motion of the conductor is now outward of the board. So this will be outward of the board, and this is these fingers represent the direction of magnetic field. So what is the direction of the current here? Upward. So direction will be upward. Is it clear? इस तरह से जनरेटर में करंट जनरेट होती है स्टूडेंट. सो व्हाट इज द जनरेटर? जनरेटर इज अ device which converts mechanical energy into the electrical energy. Here mechanical energy, what is the mechanical energy? कोई रोटर, कोई चीज को रोटेट कर रही है, इट इज द मैकेनिकल एनर्जी. फोर्स आपका अप्लाई हो रहा है इस पे, ठीक है, फोर्स अप्लाई हो रहा है, ये रोटेट कर रहा है कंडक्टर, दिस इज द मैकेनिकल एनर्जी. एंड दिस मैकेनिकल एनर्जी इज कन्वर्टिंग इन व्हाट? इलेक्ट्रिकल एनर्जी. वी आर गेटिंग द करंट हियर. Okay, so this is the Fleming right hand rule where applicable in a DC generator.